Well, that brought me to eventually a meeting with Elizabeth Rauscher and a collaboration with her. Elizabeth is a very respected physicist that has received medals of honor for work in black hole physics in the 70s, has worked with John Wheeler, many other very famous physicists. And Elizabeth and I got together, and Elizabeth had written very advanced computation and mathematics for a unified field theory in the 60s and then in the 70s, and she could never kind of get the whole key put together. And you know, when we met and I talked with her for almost 3 days, I was able to fill in a lot of things, but she didn't know, and we had to talk some more, and we had to run some calculations and all this, and she was definitely skeptical, but we started to write things, and then we thought, well, okay, if this is true, then if we look at a large scale in the universe, we should start to see very specific divisions. We should start to see structure. If the vacuum is dividing under very specific structure, then we should be able to see it. We should be able to calculate it from what we observe. So we decided to write a scaling law. And this is what came out. This is a paper that's unpublished at this time. I'm publishing other papers in the scientific journals right now that are the foundation of the change I've made to Einstein's field equation. This will follow. We presented this at the American Physical Society in Albuquerque, and here and I've presented it as well to some of the directors of the telescope here on the Big Island, and many other astrophysicists and physicists. And usually I get a pretty good reaction out of it. It's kind of, you know, jaw-dropping. What we did is we took the radius of objects, okay? And so here on the in the x-axis is the radius. And here is the frequency of these objects, the fundamental frequency of these objects in hertz. And the energy level of the object is pretty well described by its frequency. So you could think of its energy level as well. If you take the size of the universe, that is, if you look at the way the universe is expanding, you can extrapolate its size, and if you look at all the matter that's in the universe, when you place that amount of density, when you place all that matter in Einstein's field equation, the result is that the universe is too dense for light to escape it. That is, we live inside a black hole. And, you know, that was expected from me. I thought that earlier, and then I realized that as well from my own calculation before, and I thought that would make sense. Because remember, I was thinking that if for every expansion there's an equal and opposite contraction, then everything can be divided to infinity, then everything would have infinite density at its center. Everything would have what we call singularity at its center. And so I thought everything is just a different size black hole. And so I wasn't surprised about this. So we placed the data point for the universal, the 10 to the minus 17 is the universal frequency based on our calculation, and the radius is 10 to the 28. And then we place the next data point for quasars. We're taking average size and frequencies of quasars. This is a very large scale, so it's acceptable. And we place the data point. And it surprised us. It was a fairly good linear progression from universal size. Then we placed the data point for galactic centers. So we're getting smaller in scale. And again, an average galactic center oscillation rate and radius. And we place the data point, and again, linear progression. Then we place a data point for solar dynamics, stellar dynamics, and we got a linear progression again. That was astonishing. I mean, there is nothing in standard views that would predict that, other than the view I was getting that the vacuum is dividing itself under very specific structure boundaries. Then we went all the way to the atomic level with the radius and fundamental approximation of frequency for X-ray emission. And we got a data point that was a perfect linear progression, again, but this time across the boundary of quantum theory into the atomic level. So now we went from cosmological object to quantum theory level. And this is one of the fundamental fractures in our current physics. Quantum theory and relativistic physics don't agree. They don't work for each other. So that was really exciting. And then we went all the way down to the Planck's lengths and placed the Planck's length dot data point and at 10 to the minus 33. And sure enough, the progression was perfect. And that got us very excited. I mean, definitely it supported what I was trying to explain to Elizabeth and our discussion, and we started to really get some steam going, and it was really exciting to see that happen. And we thought of publishing it, but I wanted to publish first very fundamental physics to be able to explain this, not just the phenomenon. The other thing we noticed is that if you take the distance between the data point, which is kind of nice, it's sweet, and you divide them, you always get very close approximation to the phi ratio. The phi ratio is 1.618 and is, and goes to infinity. It's typical to find it in nature everywhere. You find it in flowers and shells and pine cones. You find it in the way tree divides. You find it in your body. There's a phi ratio between the end of your finger and the second part of your finger, and there's a phi ratio between the second part and the third part, and your hand relative to your fingers, and then your fingers and hand relative to your forearm, and your whole body is built like that, and so on. And so you find it in nature everywhere. So to find it on a scale that's so large was very exciting, because it supported that this would be something that nature would naturally do, that space, that the vacuum would naturally divide itself under these very specific fundamental mathematics, because we observe it in nature everywhere. And so it confirmed to us a lot of it. Now, this was my presentation at Albuquerque, and I'm going to add a little data point for our benefit here. I didn't do that there because it could you could freak out a few physicists. So the physicists in the audience, please don't freak out. But if you actually add a data point for the biological resolution, what I call the biological resolution, that is the size of the sphere of our cells and their frequency level. Now, this research has shown that there's definite resonance match at approximately 10 to the 11 for the frequency of lipoprotein of the boundary of cells. So that means the cell's boundary, all right, the surface of cells in the biological level oscillate at 10 to the 11 hertz. I mean, that's a massive oscillation. And it's funny because when we think of biology, we always think of some really kind of glooby, kind of blobby thing that's moving really slow, right? But actually, the surface, when you look on the surface oscillation of these cells, it's very intense. A lot of energy. And it just happens that if you take 10 to the 11 hertz and you take the radius of a cell and you apply that much energy into that radius, if you solve that with relativistic physics, the cell obeys the Schwarzschild condition. That is, the cell obeys the condition of a black hole. Okay, I'm not, don't panic. It's okay. But what I'm saying is that we're still dealing with the same fundamental dynamics, even at the biological level. And certainly, there's not any biology in Einstein field equation, and there's no biology in quantum theory. And, this link to biology has been looked for a very long time. Well, we were happy to find that if you place that data point for the biological cells on the graph, it would bisect the graph approximately in the middle of the graph. That is, the biological resolution is the link between the large and the small. You are the event horizon, loosely termed. And you are the data transfer boundary from the extremely large to the extremely small. Isn't that what you do? You gather information and transfer it to your internal self, which in this view has infinite boundary potential. Thus, you're transferring that information through your boundary to the infinite of the universe within yourself. And as you start to see yourself grow into that world, your worldview, your way of being in the universe, the way you are, how you are, completely changes. Because you start to see the importance of your observation. You start to see the importance of your interpretation of the field and what you are feeding the universe. Instead of seeing yourself as an insignificant little dot that means nothing to the universe, you start to see yourself as the center of creation. Now, you might think that's arrogant. I think I've heard something along those lines from the new Pope or something. But I would like to say that if you have come to these conclusions, you must have come to these conclusions finding out that everyone else is the center of their universe as well. And thus, we are all equal, and we're all one. But beyond the philosophical views, the fact that the biology would fit on this graph, the fact that we could start to see the information feedback loop between the radiative side and the contractive side starts to open a whole new field of physics. For 20 years, and I've been saying this for a long time, I've been saying that information doesn't just flow into black holes, but flows out of black holes as well. And I got in a lot of trouble for that. And it was nice to see that just recently, Stephen Hawking has made a public announcement that he now believes, after 15 years of refuting this, or 30 years of refuting this, that black holes have information radiating out, coherent information. Before, they only had Hawking radiation, which was thought to be generic and incoherent. So now this is actually coming to the forefront. It's very exciting for me because finally I feel like there is some support. It was very recently that these announcements were done, and as well, to me, it was clear very long time ago that if this was true, then the center of all galaxies had to be black holes. So I predicted that, and then eventually they found that that was the truth, and although I got in a lot of trouble for saying that early, and so on. And so I start to see the infinite potential of everything present in everything. Okay, so now we've got divisions in the vacuum. What dictates those divisions? How is the vacuum structured? If the vacuum is divided in very specific ways, then it must have very specific division structure. Then the vacuum has structure. How can that be? And what would be the structure? I wanted the key to the equation of vacuum division. I wanted the key to the creation of these boundaries. Because if I knew the key, then I could create one of those boundaries. Now, let's go back in time a little bit, and I'm in high school and I'm not doing so good. I'm still not doing so good in the educational system. And it's funny because my father worked with Piaget and is well-respected, child psychologist and so on. And he had all sorts of trouble with me. And at the age of 16, I'm done with the whole thing. And okay, if I have to live doing something else, then that's what I'm going to do. And I decided, since I was a good skier, to become a ski instructor. I was in Alberta at the time, and then eventually in BC, in Canada. And I'm getting tired of it because I'm freezing every day. And I'm tired of freezing every day. And I want to do something else than sit on a cold chairlift. So at the end of one season, I decide, listen, I'm a good scuba diver. Maybe I should try teaching scuba diving in the summer so I don't freeze all year round. So I opened the map and I just pointed. And my finger landed on this island called Isla Mujeres off the coast of Cancun in Mexico. I pulled out my English-Spanish dictionary and translated Isla Mujeres, and it said Island of the Women. And so I was a ski instructor, so I was like, oh, I'm there, So I got to Isla Mujeres and I started teaching scuba diving, and I'm having a good time, and I get a few days off, and it's like, okay, let's go and visit, ancient sites and stuff, something. So I get out there in the buses with the pigs and the chicken and everything, and I'm going through the jungle, and then I come upon these pyramids, Chichen Itza, just out of the jungle, these huge pyramids sticking out, freaky. And I, went and visit, and so I'm taking pictures of the pyramid, and I climb up the stairs, and at the top is shaded, so I'm happy to get there, and I'm sitting in the shade, and I'm kind of doing a little meditation, try to feel something. And I hear, tour guide coming up and with tourists. And I'm listening to what he's saying in the background. And he's talking about how these people move these stones from the quarries that are miles away across the mountains and down and so on, and then brought those stones and put this pyramid together, and how they use copper tools to carve it and all this stuff. I'm listening to all this, and it's freaking me out, because it's like, I remembered the lessons I had at school about antiquity and so on, and the pyramids of Egypt and so on, and how improbable those theories seem to me. But, you know, I'm listening, and he's talking about cutting stones with copper tools. I know that copper doesn't cut stone, and so on. And I'm having a really hard time with this whole thing, because I'm looking at the dense jungle around me, and I'm like, wow, you know, how did they get those rocks here? And then he talks about how precise this pyramid is and how it's aligned to the solstice, so that when the shadow hits the corner of the pyramid on that very specific day, it casts a shadow that generates the body of a snake going down the stairs with the head of the snake carved at the end. I've got a pretty good notions of engineering and astronomy and so on, because I've done a lot of study in that, independent studies. And I'm thinking, I'm listening to this, and I'm thinking, whoa, man, this is not easy. You can't just whip that out. Or you can't, no, you can't just have the pyramid built and then, like, on the right day, just get Joe to pick it up and align it. Little bit to the left, Joe. That doesn't work. Can't do that. So I'm listening to this, and I'm kind of confused, but I'm interested. And then I start to think, well, wait a minute. I'm looking for a fundamental structure of creation, and there's these buildings, these pyramids everywhere around the world. And I'm thinking, well, why are they all building pyramids? Why did the Egyptians, the Mayans, the Incas, all these people are building pyramids? What's with pyramids?